Okay, towards the end now. So 19. Three real numbers, x, y, and z, satisfy x greater y greater than z equals to 1. No, greater than 1. Which one of the following statements must be true? Okay, so again, if it says must, then the general direction of the question is to find counterexamples. Okay, for example, A, like, is there a counterexample to A? Well, yes, right? Let's say I put x to be massive, because I try to make this wrong, right? So I want the left-hand side to be really small. Well, if I want this to be really small, just chuck in infinity, right? Okay, now, you shouldn't chuck in infinity, because infinity is not a real number, but you get the idea. You chuck in 999, okay? Chuck in like 100 million nines. Well, then the left-hand side is definitely smaller than the right-hand side, yeah? So A is wrong. Okay, B. 2 is greater than the right-hand side. Okay, how can I make the right-hand side big? You tell me. Same thing, right? Chuck in x is 10 million nines, then you'll be fine. And it's definitely bigger. And then choose y and z to be 1.5 and 1.6 or something. Okay, good. Okay, how about C? So can we find a counterexample for C? Actually we can't. Okay, so we have to prove it though, right? So let's try to prove this. How do we prove it? Let's try to write this in a nicer form, so that it's comparable, right? Such that both sides are comparable. Over 5 to the y. Okay, why is this true? So let's look at top. Well, x is greater than z. That means that 5 to the x is greater than 5 to the z. Okay, that's fine. Numerator, check. Numerator, good. Denominator, 5 to the z is always smaller than 5 to the y. And we know that all of these are positive, right? 5 to the something is always positive. Fine. So this is also okay. The denominator is also good, right? Because 5 to the z is smaller than 5 to the y. Okay, so C is correct. Now how about D though? Can we find a counterexample for D? I need the right-hand side to be smaller. Okay, this is also actually quite easy, right? Just find x and y to be numbers which are really close to each other, and then z to be something really small. Let's say take z as 2. X to be, well, doesn't matter, 1001, let's say, and then y is 1000. Well, then that's definitely smaller than 2. There's no way that's greater than 2, right? Okay, cool. So yeah, there we go, I suppose. Oh no. This is actually greater than 2. No. You have to choose something really close. 1000.000000001. Okay, let's say we do that. Okay, then that's definitely close enough, I suppose. All right, and that would be less than 2. Okay, so quite a trivial question actually. Just make sure we find good counterexamples.